What's up, people? Welcome to your review answer video. Today I'm going to walk you through all the questions that you did for this review today to get you guys ready for the culmination of this chapter, testing on functions and inequalities. So let's get right into it. Problem number 1. Mrs. Edwards spends $2.50 for each Brightside Skittle bag she buys. Part A. Write an equation to represent the number of Brightside Skittle bags. B. So we don't know how many it is. And the total cost. C. Because we don't know what that is either. So, the equation would be the total cost for buying these Skittles is going to be equal to $2.50 times the number of bags she buys, which we don't know, right? So that's our variable B. But we need to show 250 times B. So that's 250B. So the equation here is the total cost is equal to $2.50 times however many bags she buys. So C equals 250B. How many Brightside Skittle bags can she buy with a $10 bill? So the idea here would be that the total cost would go in. We put 10 here equals 2.5b is the same as 250b. And then you can just isolate your variable, divide by 2.5, and you find out that she can buy 4 bags of Brightside Skittles. Number 2. What is the missing value for the distance Bobby Joe walked in 3 minutes? Well, if we look here, the number of minutes, this is kind of blurry. Let me see if I can. It's a little better. If we look on our graph here, we can see that the number of minutes and the distance Bobby Joe walked is 1 to 2. We can't really tell much from that, but it's got another one down here that shows us that from 5 to 10. You might think that it's maybe adding, but it shows clearly to me that we're multiplying here by 2. 1 times 2 is 2, and 5 times 2 is 10. So if we take this middle value here and we do 3 times 2 to figure out what this is, and 3 times 2 would be 6. So the distance he would walk in 3 minutes would be 6. 6 what? I don't know. 6 miles? Oh. Number 3. Let's see here. Number 3. Write an equation to represent Susie's distance and the number of minutes. So we need to find out Susie's information here. So in 1 minute she goes 4, in 3 minutes she goes 12. Very similar to Bobby in the last problem. It's multiplying, but in this case it's multiplying by 4. So which of these shows the number of minutes being multiplied by 4? Obviously neither of these additional ones, but we have these two choices here. And this one is actually showing her distance being multiplied by 4, but that's not what's happening. It's the minutes that's being multiplied by 4. So this is the answer we're looking for on this one. Number 4. The average speed of a jet is 600 miles per hour. Part A. Write an equation to represent the distance in miles that the jet travels in any number of hours. So very similar to problem number 1 on this today. The distance miles is equal to 600 times however long it travels. So m equals 600h, or that could be reversed. Part B, the jet will be flying for 12 hours across country. How far will it go? Well, we just plug in 12 for our variable h, which is hours, to find out what it would be, right? That would be m equals 600 times 12. Just substitute it in. And then off to the side here real quickly, I can just do 600 times 12, 0, 0, 12, 0, 0, 0, 6, 7,200. The jet will go 7,200 miles. Number 5. Mrs. Edwards plans to make some peach pies. She buys peaches for $4.25 per pound. Which of the following is a function equation to determine the cost of peaches for any number of pounds? So what we're looking for is the equation that shows what's going on here. $4.25 per pound would be the total cost, C, is equal to $4.25 per pound. This is the multiplication problem, and we're looking to multiply the pounds times 425. A big mistake we might get here is you might choose this one here, but then you're multiplying the total cost times 425, but we don't know what the total cost is, right? That's not the dependent or the independent variable. So it's the pounds that we want to multiply by 4.25. Number 6. What is the total cost of 8 pounds of peaches? Based on the last problem, we just plug in 8 to the equation, and we multiply 4.25 times 8, and that's 20, 32, 34. Just like that. Number 7, the table shows the total cost of admission to a water park for a different number of guests. Select 2 statements that are true based on this right here. So the first statement we'll go over is the equation C equals 6G can be used to find the total admission for G guests. So basically what it's saying is that the rule is to multiply by 6. So let's check. 2 times 6 is 12, 3 times 6 is 18, and 4 times 6 is 24. So it looks like this is most definitely the rule for this. So that is the equation. This one says the equation is the total cost is G plus 10. That's definitely not it, because it works for the first one. 2 plus 10 is 12, but 3 plus 10 is 13, not 18. And we already know the rule. So that's definitely not the answer to this one. The equation is G equals 6C. No, it's the same written as this one, but the variables are different, and that's not true, right? We're not multiplying the total cost times 6. We're actually multiplying the number of guests times 6 to get the total cost. So this is not true either. The total admission for 6 guests is 36. Well, for 6 guests, that would just multiply by 6, and that would give us 36. So that is a true statement. That means that this one must not be true, but let's just make sure. 17 times 6 is 42 plus 60 is 102. Oh, this is 120. That's not correct. So those are 2 answers for number 7. Number 8. Which of the following function equations best represents this graph? So if we look on the graph here, and I love how we have the hint here that says make a function table. You just have to find out the rule. If you can find out the rule, then you'll know it's either multiply by 5, multiply by 6, add 5, or multiply by 2. So let's go ahead and take a look at some of these ordered pairs. So I'm going to make a quick table real quick of my x's and my y's. My first point here is at 3, 8. So x is 3, y is 8. My next one is at 5, 10. X is 5, y is 10. My next one is at 7, 12. So I need to look at my relationship between all of these and see what's going on. Well, I can check them. Are we multiplying by 5? 3 times 5 is 15. No, this is definitely not the answer. Are we multiplying by 6? 3 times 6. Nope, that's definitely not the answer. Are we adding 5? 3 plus 5 is 8. That's true. 5 plus 5 is 10. That's true. 7 plus 5 is 12. That's true. So this right here looks like the answer. I'm just going to check this one real quick. Are we multiplying by 2? Well, 3 times 2 is 6. That's definitely not the answer. So the only good answer and the right one is definitely y equals x plus 5. Number 9. Write an equation for each function below. Okay, so we need just a rule basically for each one of these. And I know that my equations are going to start with y equals on all of these, right? Y equals something. And then we just say, what are we doing the x? Well, the x here is going from 3 down to 1. So it's either subtraction or division. I know that automatically. So it could be minus 2. So let's see if it works for the next one. 6 minus 2. It doesn't work for that, so it must be division. It must be division. So let's see what we're doing. 3 divided by 3 gives me 1. 6 divided by 3 gives me 2. And 9 divided by 3 gives me... So the rule must be divide by 3. So we take x divided by 3. The rule is y equals x divided by 3. This next one, we're going up in numbers here. So we have to find out what we're increasing by. And this one we go from 2 to 15. We could be adding, we could be multiplying. 2 times something will give you 15. It could be, right? It could be a decimal because we have a decimal here. It's not going to be addition because 2 plus 13 here and 3 plus 13 doesn't work. So it's going to be multiplication. But what are we multiplying by? We can actually do some quick division to find out here and see. 15 divided by 2. If you do that real quick, off to the side, 15 divided by 2. 2 goes into 15 7 times, which is 14. Gives me 1 left over. I can do a little decimal action here, and 2 goes into 10. 5 times, actually 7.5. So if that works for this one right here, if we do 3 times 7.5 to get this, then that must be the rule. And it actually is. And 4 times 7.5 would give us 30. So the rule is to multiply by 7.5. So it's just 7.5x. Part C. Down here, we go from 0 to 6. I automatically know this is a multiplication because there's nothing I could multiply this by to give me 6. Okay? So it must be some kind of addition. Okay? Let's see here. 0 to get to 6 is just add 6. 3 to get to 12 is add 6. Well, then it can't be addition either because that doesn't work. So it could actually be a combination of multiplying and adding. So to get from 0 to 6, I know I'm going to add 6. That has to happen there. But what do I multiply by to get to that point? Well, let's see. Plus 6 to this would give me 9, but I need it to get to 12. So I must take 3, multiply by something, and then add 6 to it to get 12. 3 times 1, that would be 3 plus 6 would be 9. That wouldn't work. 3 times 2, that would be 6 plus 6, which would give me 12. So maybe it's times 2 plus 6. 6 times 2 is 12, plus 6 is 18. So it looks like the rule is to multiply by 2, and add 6. And there we go. Number 10, the equation y equals 10 minus 2x is given. Select 3 y coordinates that would fill in the function table. So if the rule is right here to do 10 minus 2x, I just plug 0 in to there. And 2 times 0 would be 0, and 10 minus 0 is 10. This next one would be a 1, so that would just be 2. 10 minus 2 is 8. The next one is 2. 2 times 2 is 4, and 10 minus 4 is 6. So it looks like 10, 8, 6 are my numbers here. So 10, 8, and 6 are the values there. Number 11. What is the rule that represents the relationship between the position n and the value of the term? So we're trying to find out what the rule is. And then determine what the value would be in the 20th position, right? If this graph went all the way to 20, what would that term be? Well, let's see if we can find out the rule. Is it well, it's going up, right? 1 to 5, 2 to 10, 3 to 15. Maybe it's addition or multiplication. We'll get to 1 to 5. You can multiply by 5 or add 4. On this one, you could either multiply by 5 or add 4 to get there. It's definitely not add 4, so it must be multiplied by 5. 2 times 5 is 10. 3 times 5 is 15. So the rule is to multiply by 5. And it says here the rule's multiply by 5. That's the only one that says that. So if you know the rule, that's the only one that makes sense. The term in the 20th position would be 100. Well, 20 times 5 would be 100. So here's your answer, number 11. Number 12, which is the correct expression for the table above? Again, we're just looking for the equation that represents this rule to get from 1 to 7, 2 to 8, 3 to 9, 4 to 10. And all of those, you are just adding 6 to the number above to get the one below. So the rule is to add 6. So the correct one will be C for this one, right? So just do n plus 6. Number 13, what are the input values for the function table below? This one's kind of cool because it's kind of working backwards. We know that y is 41, so what would we have to start with in order to get 41? Well, something times 4 plus 1 would have to be 10, right? 10 times 4 would be 40 plus 1 would be 41. How about 13? Working backwards, 4 times something plus 1 would give 13, so I need to subtract 1. Right, I could kind of do inverse operations if I wanted here to figure this out. 4x plus 1 equals 13. I could do minus 1. And I showed this to some of you guys, a two-step equation. It's a little difficult, but and then divide by 4. And you get 3. So 3 would be my x value there. And then on this one, so that's 10 and 3. And then on this one here, to get 65, I got to multiply something times 4. And then add 1 to get 65. So the adding 1 would mean I would be at 64. So 4 times what would give me 64 is the question. The only one that makes sense here is 16. If I do 16 times 4, does that give me 64? 24. Yeah, that gives me 64. Plus 1 would be 45. So that would be 16 on this one. So there's your answer for number 13. Number 14. Which x value is a solution to both inequalities? So I need to try out these to figure out which one is a solution for both. Let's start with 80. 80 is less than 81, so that's true. 80 is greater than 68, that's true. So this one works. Just to make sure, let's try this one. 88 is less than 81, that's not true. So this one's not the answer. 85 is less than, no, it's not true either. So the only good answer and the right answer here is x equals 80. Which two values are solutions to the following inequality? The inequality says x is greater than or equal to 50. So I need any value that is greater than or equal to 50. 0 is not greater than or equal to 50. 50 is greater than or equal to 50. 51 is greater than or equal to 50. 49 is less than, so that's not correct either. So there's your two answers for number 15. Number 16, what is the inequality for the following graph? Well, the following graph has a open circle, so I know it's either just going to be less than or greater than, not equal to, and it's going down, right? So we're looking for numbers less than 3. So our number x is less than 3. So the answer to this one is all numbers less than 3, x is less than 3. Number 17. Choose the graph of the inequality x is greater than 1. Okay, so I need all the numbers greater than 1. This one right here shows numbers greater than 2, so that's not correct. I need greater than 1. This one shows numbers greater than 1, and it's an empty circle, which is true because we don't want it filled in because it does not say greater than or equal to. So I think this one's the answer. Let me check these ones real quick. Oh, this one says less than 1, so that's not true. This one also says less than -1, that's not true. So our answer is this one here. That would be graph B on that. Number 18, water boils at 212 degrees Fahrenheit. Which of the following inequalities is true only for temperatures higher than the boiling point? So we're looking for temperatures higher than the boiling point, which is 212. I need numbers higher than 212. Numbers greater than 212. The temperature is greater than 212, and that one is T is greater than 212. Cannot be equal to it. It says it has to be greater than it. And then finally, number 19 here. Jake is younger than Sophie. Sophie is 14 years old. Write an inequality using J for Jake's age compared to Sophie. J is younger than her, so his age is less than Sophie's age, and Sophie is 14. So Jake must be less than 14. Cannot be equal to because it does not say that he could be her age, just less than. So we're looking for J is less than 14. Good luck on the upcoming test or quiz that you guys are taking for this. Have a good day.